everyone, welcome back. Yeah, this week was probably going to be quite a short one. I'm a little bit tired from the weekend, and I haven't thought of a huge amount to do in this session. Just thought that I'd just log in because I quite like to do one a week. So that's what I'm trying to force myself to get into that rhythm. So yeah, I guess the first thing to do is see where we are. So I can do that by running trunk serve to serve up our application. Got a couple of warnings there. We can go to this link here, see our game, again with the rather bland looking menu. We click on there, we've got our room. And that room, we should be able to fire fireballs, which we can. And we can see that they respond to how close the wall is. So when you're firing at a near wall, they don't last very long. When you fire at the back wall, they last a long time. And then they leave a scorch mark from there. So I think the thing that I'd really like to do this week is start to add in enemies and have them be able to move forwards and backwards down the corridor in order to get the perspective sorted. So first thing we want to do is go to our application. We're going to, this is the Pixel App application. I keep forgetting to put a link in the comments, but I will do that this week after the stream is finished. And yeah, you can. It's available on GitHub as well. So it should be stored in next to the game, which is currently called VCC clone, because originally it was going to be a Virtua-Cop clone, but it's kind of taken on more of a wizard theme as we go. So I think we'll just call this enemy wizard for now. Sprite sheet for the enemy wizards. And the size, gosh, that's a good question. So the whole screen is 800 across when it's at the front. So basically, I think that's probably how wide we want it when it's right in front of us. So probably make that 100, which is obviously 1/8 of the size, and the height, probably want it to be a little bit taller. I was sort of picturing quite squat, quite dumpy dwarf-like wizards. You'll see what I mean, I think, as I go through the design. And I'll first make it 10, actually I'll make it 12 pixels, because that divides 12, 6, 3. It divides 3 times, so we can get the fine-grained thing at the end there. Fine-grained pixels at the end. So I think that's all correct. So we'll create that and we'll see. Yeah, that looks like a pretty good size. Oh, yeah, some other updates to the Pixel app that I've pushed. I put icons now instead. There's also a fill function. You get this text in the top right that displays the thing. There's erase, move, sample. They're very, very crude drawings, as you can see. I'm hoping to improve those icons later, but for now, they're replacing what were single letters in there. I've also done some work on the way the paint tool works. So now when you drag it, in fact, I'll show you, I only click once and then I just drag and it just draws a line. I think this is going to make things a lot easier. Excuse me, and same with the erase tool as well, but it's going to make things a lot easier when drawing these diagrams. I'm actually going to refresh the page. So it doesn't save, because the way that it saves those is saves them actually as pixels, but just with a transparency of 0. Excuse me. And so yeah, first thing I quite wanted, I've been sort of picturing in my head like a purple wizard. So I'm gonna go for a lightish purple, and obviously a pointy hat. That, yeah, we'll get the hat going. Then we need a skin tone. Actually, I was thinking maybe give them shadow faces, and then with glowing red eyes. This is very dumpy, isn't it? Yeah, the hat's too big there. That's gonna have to take the hat down. So yeah, more like a little sort of cowl type thing. Make that face. It'd be quite good to get the. I'll change the shoe color in a minute. We're just sort of blocking out at the moment. So if the arm goes there, so that's like an arm sort of thing. Raise that. Yeah, that works, I think. Cool, so as a block out goes, I think that works quite well. Next up, we'll draw the shadow face. Oops. Just put those in there. And then finally, the red eyes. So pick a red. Yeah, that looks good. Oh yes. Yeah, I like that. That's going well so far. One of the reasons I wanted the sort of the bobble on top was I thought that it might be quite funny or fun, at least, to have the bobble like move from side to side as they walk around. Take that off. Yeah, I like that. So I'm going to save that, and then I will double the pixels. So this should, yeah, there's a bit of a bug here, and I've not quite figured it out. But it overhangs on this side, so like chops off, and it won't actually be rendered as part of the image. You see, it's cut the feet off as well, which is very strange, but we will correct that now. It's starting to look a bit more like a crab. So I'm not entirely convinced by. But we can cut the arm out, and is that, yeah, that's even, isn't it? Sort of. No, it's not even. Why is that not even? It's not even putting them in the middle. Gosh, I really need to sort this algorithm out. I think we can move the hat up a little bit. No, I think I'll put that back. We'll make this where the hat ends. And then I'm going to put some shading in here under, like, where the brim of the hat is. I've fixed the shading portion. In fact, you know, I might even make the hat wider, like make it a real sort of wide-brimmed wizard's hat. Now we've got this problem of it not being centered, so I'm going to try adding that in. That's better, and I think this is the center point, so I'll put that one back in. Nope, actually preferred it without, so have it leaning to one side. Maybe, yeah, like that. Yeah, that works for me, and then we'll go back to, yeah, I think we want that there. Then the faces, sorry, sample the black, took the thing, there we go. Oh, actually, I do quite like the eyes being slightly off center. Let's see what happens when we take that out. Make that black. Yeah, then the eyes could move in between frames. That would be cool. Try and notch in a little bit at the bottom. Okay, so that's all centered. Now it's just the arm that isn't. Cool, so I think we're centered again now. So I think we can save that. Just wait for it to go, and then double the pixels once more, and this is the last one, so each pixel should be 3 pixels wide now. It should have been 12 to 6 to, and if we look here, yep, pixel width of 3. So that, I think that works. That's good. A good amount, and it's kept it centered this time. So I don't know what was going on with that first doubling of pixels. That's definitely a bug I need to work on, but it's still centered this time, and we can still get in here, so I can start to notch out some detail on the hat, for example. So let's. Yeah, that's better, I think. Notch out of the hat. Oh, monitor's trying to turn itself off. Actually, I think instead of doing that, I'm going to have a look at the side. Let's put that back and actually go. Yeah, I think I prefer that actually. Having the brim stick out just above the top there, and then we need to mimic this side by filling in these big steps here. Yeah, quite happy with that. I will. I'll fill in these bits on the arm. Do that on both sides. And one for the foot. Here. Did I do one? Yeah, I didn't do one for the thing. Okay, no, that works. I think anyway. Right, so now we can start to add some actual detail in here. But first of all, I will save it. Just wait a second for it to actually save. There we go. So, yeah, I might try and clean up the eyes a bit. Oops, sample, paintbrush. So my thinking here is that as the eyes move, essentially this black blob will move to like here, for example. Yeah, so the black blob will move around in there. Is that right? Yeah, yeah. So that could move. We can have that in different locations. For that, so I don't understand why. I think actually I want to move this across one, and then move this across one. Wait, was this? Oh, that was the wrong one. Let's put that back. Red, just like the paint tool. Oh, I've rubbished this up completely. So 1, 2. It's the problem with talking when I'm doing this. So that's the square. Yeah, and then, okay, right, and then here. With the eye there. Yeah. But then they're not. I think maybe I want to put them further apart actually, so we can have 3 and then 3, 1 in the middle. Yeah. Sample of black, and oops, keep doing that. 1, 2, 3, 1, 2, 3. There we go. And now we can put the eyeball in, and yeah, there we go. So we can have the eye there. In fact, actually, let's put the eye in the center to start with, and then we'll do the, actually, I quite like that with the two pixels to represent the eye. Yeah, that's good. And then other than that, I'm thinking like a faceless type of thing. So now with the sample tool, I'll sample the cowl because I quite want to move that in a bit like this. Have it coming up to obscure a bit more of their face. Yeah. Starting to look a little bit like a frog. Have to be careful about that. But yeah, other than that, I think that's excuse me, that's pretty good. Okay, so now pick some. I need to pick a color for the hands. I'd quite like them to be sort of ethereal. So maybe I need some sort of something for the hand. Maybe a grey hand. Let's have a look at that and see what. Why is that not working? There we go. Yeah, maybe give the impression they're wearing gloves. Yeah, I like that. Might actually take a few pixels from here, make the arms a bit more prominent, and then I might put a little like, I might use the same grey and just put like a tassel on. Yeah, I don't think that works. I think it clashes with the hand too much. I think I might have to change the colour on that. Maybe like a yellow. Yeah, let's go for like a yellowish tassel. Really make it stand out. Okay, well that did not go as expected. But I do like the yellow. But actually let's filling all of that in. Yeah, give them a nice like waistband thing. I think that's cool. What I will do, I will add in a little like necklace thing, like a medallion. I'll say that's where they get their power from. In fact, actually, this would be a great way to represent the type of wizard. So one of the thoughts that I'd had with this game was to have them cast different types of magic, and that we could represent that with the stone that's in the inside this amulet. Yeah, I like that as an idea. So first one, we'll go with a green just because it's very different to the other colours that we've got in this palette. Doesn't stand up massively from the grey chain. Might make the grey a little bit darker. Just make sure it's even as well. So 1, 2, 2, 3, 2, 1, 2, 3. There we go. That's there we go. Now it's kind of even, and then finally just to update this. Great, cool. Well, that's nearly ready, I think. Just need to pick a colour for the shoes. I think we should give them brown shoes. That's a nice brown. Sort of impression of like hobnail boots. Three. Do three there, do I? 1, 2, 3, 2, 3, and then 1 down there. Cool. Now I'm going to save this. I'm going to test out the new fill tool that I've added. Oh yeah, it almost worked. Just didn't quite get those ones at the edge. But that's okay, we can add those in by hand. Awesome. So it's really starting to take effect, I think. Yeah, I'm actually quite happy with this. I might add a little bit of shading in. So add the shader layer, change the shader. At the moment, the shader only works in black basically, and you select how the opacity of the black coming out, but I'm hoping to improve that in the future. Now I wanted to put like a darkened brim here, and so we'll see in a second. So this is actually sitting on top of the color layer, and the reason for that is so that you can actually change the color when you render, and I'll give you a demonstration of that working as well. But just going to shade around the edge of the cowl, definitely up here. On the bottom as well. Cool. Let's just give it a bit of effect of depth. And then other than that, just going to go around the edge. Make sure I get all the edges as well. Give it a kind of outlined effect, I think. Well, that's the hope. Won't do the gloves. Will definitely do the shoes. I actually had a slightly different idea for the sole of the shoe, which I will explain in a second. Yeah, I won't do that last little bit. I think that's what I did on the other side. Yeah, and then I went all the way down to the bottom. I'll do the rest of the shading first, just to get that out of the way, and then I'll explain what I thought about with the shoe. Basically, it's to use a darker color to give the impression of a sole. And then I will put this in here. I won't change any of the shading on. Actually, maybe I will just on the edge there, and on the tassel. Just make it slightly darker. Yeah, so it looks like it's inside the shadow of the arm, which I quite like. So yeah, so we've used a 50% transparency. I'm now going to use 0.8. This may not work the way. Yeah, no, it does work the way I thought. Okay, so it's the same shoe color, but the sole is now darkened by this different shader on top. I'll just show that that's the case. See, when I remove the shader layer, we get rid of that. That there, cool. And yeah, so now it looks like there's a proper sole on the bottom of the shoe. With the shader, I'll go back to 0.5. I just wanted to go around the hat a little bit. Think might revisit this at some point to kind of add some more shading, so there's a bit of a like gradient. Raise that. Oh, it's not erased the shader layer, it's only erased the image underneath. Okay, that's a bug. So come on, stop. Okay, that's interesting. Right, I'm going to save this because I don't want to lose all my shader layer. That is quite annoying. I can't sample that purple again. Okay, well we'll leave that hat for now. I'll come back and do the. Maybe it's because I didn't. Maybe it's because I didn't have color selected. Yes, it was because I had the shader selected, so it was trying to update the shader. Okay, right, put that oops, put that back in. Right, and the way that we do this is we set the transparency to 0, and then draw on there, and that'll update the shader. Cool. Okay, so what were we doing? We were doing 0.5. Oops, 0.5. Cool. And we'll go back to drawing the hat here and just doing these corner pieces. Yeah, I'm going to leave that. I'm not going to do this part of the brim because I want it to stand out from the lower part of the brim. Oh, I like that. Happy with that. Okay, so if I save that, and did I hit save? I did. Awesome. And then we go back, we go to saved images and scroll down to the bottom. We can then do a render. And this is where the shader stuff comes in, because we can substitute any of the colors. So we can take that purple, for example, and substitute it for, say, a blue. Let's go for a slightly lighter blue. And then when we do the render with colors, so we get a blue version of the same guy. And we can, we can substitute any color in there. Could have let's go with a goldish wizard. Render with colors. There we go. You see, we can really quickly get different enemy types, which is why I've used this application to do this with. But for now, though, I will just get a single image sheet, and we will do save image as. And save this as enemy wizard in there. Cool, and that gives us our enemy wizard to play around with. And there he is in our application. So now we're going to go to the codes, and I'm actually going to create a new module here, and we'll call it characters. The reason is I can kind of see this getting quite big later, so it's not really an asset. Assets reserved for the walls and the fireballs and the effects, and then we'll have one for characters where we pull in the different wizard types from here. I'll call it enemy wizard for now. That's very poor naming on my part because it will inevitably be that there will be multiple different types of enemy wizard at the end, and we'll just have to wait and see how that goes. So in the module, pub mod enemy wizards, and in here is where we'll create our public struct enemy wizards. And this will have a location. So did we create in the utils? We did create the point last time. So we will use create utils point, which is a good point. I need to add the mod characters in there in order to be able to pull this in and get it rendering. Excellent, cool. And now IntelliSense has caught up and is telling us that we're not using actually, maybe location shouldn't be public, but that's a point. See, I think for now the point, the point is probably all we need. Now, I came up with an idea in the week, which is to treat the corridor as a so this corridor here. Treat this as a 100 by 100 square, so that 0, 0 would be this back corner, and this would be 0, 100, and then this corner here would be 100, 100. And then when we're rendering, we calculate where on the floor they're standing, how big they need to be, and how far left and right. Obviously, if they're stood at 0 here, if they move halfway down the hall, the x coordinate needs to then be here, and then if they're all the way down the hall, then they need to be here. But for now, we're just going to like have them pop up right at the front, at the beginning of the corridor at full size. And then part of what I wanted to do today was make them walk backwards and move down the corridor, and watch them follow that wall down here as it goes back. It's likely, because these walls and the floors are so crudely drawn, which I do hope to address at some point, but I wanted to kind of see what the furniture was like when we make those. I wanted to have pillars and things going down, like I wanted to have pillars come down at intervals along the corridor. And I think once those are in, then we'll get more of a sense of the aesthetic, so then we can actually block out the floors and kind of paint them properly. So yeah, anyway. So then we want to implement enemy wizard. And gonna just steal, I learned a new key combination for Visual Studio Code. And it's not working. There we go, yeah. It's, you hold Control and then you press K and then 0, and it folds everything for you, which is great. So it folds up all the functions, makes I find it makes navigating through files much, much easier. So we definitely want a new, I'm gonna leave these here as errors. And we want an update and a render, and we want the get location and get distance. In fact, the get location we can just copy and paste because that will be identical. And the distance, yeah, we want to be able to get the distance because we want to be able to check it against the fireball distance to see if it's in the same Z depth, because we're essentially faking that. But for now, I will mark this with a to do. And in here, we want to take in an X coordinate and a Y coordinate, and we return self, and we return an enemy wizard type with lock is going to be point new X and Y. Awesome. And then we wanted the update functions. What's the signature for update? Is literally just this. So I'll copy that signature. For now, we'll do nothing. And the render takes in a rendering context. So let's. Cool, and that doesn't recognize that. See if IntelliSense is going to help us out here. It is, awesome. Great, so we've got our first enemy. Now one thing the enemy is definitely going to need is an image, and that is of type HTML elements. And it's also going to complain because that's in WebSys. Great, and now it's complaining that we don't have an image to go in there, and we just need to, in fact, I'm going to just copy this straight over from the Fireball new, or the Fireball constructor here, and the image, and the only thing it's complaining about there is the constant that we've got, so that's going to be enemy wizard image, and I'll specify the type. Again, I'm going to copy this in from here, just because they're in the same folder. The enemy wizard.png, and we need substitute that. Cool, so we've got that. I guess the first thing is going to be the render, because it's going to be very hard to debug if we can't actually see where it is. So we'll ignore the update for now, and I will just come and consult the, yeah, in fact, I'm going to copy the actual draw image from the context here, because we need to do that. We can do self.image. I'm just going to complain because it's going to complain, so it needs to be a reference. Excellent, cool. And now we need to, so the offset's going to be 0, 0. We'll update that in a minute because I want to add the want to add some animations in, like particularly walking animations. I think would be really cool. Once we've got the sizing and the distancing, so that it goes down the corridor, we can start to add those in. I quite like the idea of them appearing from like a doorway, like on the left or right here. So we can put a doorway in there and have them scooch in, and then walk down the corridor towards us. I feel that would be kind of nice and threatening. Not that threatening is often a word you use with nice, but I mean for a game, you need to have some level of threat going in there. So yeah, but for now, we'll just render. We just wanted to render at the front. So the size width, we're going to need constants for these as well. Enemy wizard frame width is going to be of type F64, and that will be, now how wide did we make it? I think we made it 100. Can check by just coming here and checking the bottom right, by 150. So const enemy wizard frame height is going to be 150. We've got double colon there, double semicolon. Cool, and then our location is going to be, we're going to have to calculate our location. So it needs to be, if it's 0, 0, it's going to be the wall width. So yeah, sorry, I'm just trying to think this out. If it's 0, 0, it needs to be here, which is going to be, what is that, 340, but minus a little bit. So let's call it 348. Oops. Accidentally clicked. Right, 348, and the center of this is obviously going to be 400, so it's 400 minus 348. 400 minus 348, which will be 52. And I'm going to assume that this is going to be largely the same on this side. So 400 would then be 452, which takes us here, which, yeah, that works. Okay, so 452. So that's at a maximum depth. We're going to have a variance of 104, and then we'll need to normalize that to the center point. Okay, and then at the front, it's going to be all the way from 0 to 800. So for now, we will just treat it as though it's in the foreground, like the complete foreground, and we'll make it full size there. So 0 to 800. Yeah, essentially, it's just going to be that, isn't it? So the x position that we need to create is going to be the self.lock.x. It's going to go from 0 to 100, so we need to multiply it by 8. Yeah, because that's what we said is 100 across, so we'll just treat it as a percentage, essentially, of how far the percentage across the hallway that we've got. So we get that by 8, so that's from 0 to 800. Then, so that's the start location, then we subtract the enemy wizard frame width minus, actually, we need to calculate the output width. And for now, we'll just make that this width, but obviously it will vary from the size, but depending on how far down the hall they are. So let's do output width over 2, so we need to move across 2. And y is going to be, this is interesting because the position is actually on the floor, so we want the y, the output height, to be the exact, yes, it's going to be the self.lock.y. Oh no, that's even more complicated because we said that 100 is going to be, so it's actually going to be, how far down does this go? 347. I'm going to call that 350 to stand in front of the wall. So it's going to go from 350 to 600. And we're going to have 0 to 100. So we need to map that onto this range here. Sorry, I'll show you what I'm thinking. So 0 is going to be here and 100 will be here. But we need the calculated heights to go from 350. So our calculation is going to be 350 plus, and then the multiplication of the difference there, which is 150. So we can actually just multiply by 1.5. Oops. Why has this got such a complicated type? What happens if I do that? Tell it that it's an F64. Ah, that's why. Didn't like that. Okay, makes sense. Force that to be F64. So this, the location, we just multiply by 1.5 to get the real world location. And it's going to be the game, we're going to need access to the game width and height. Did we create that as a thing, or did we just hard code it? Yeah, okay, cool. Let's make these public. And actually, I'm going to move them into main. It doesn't make sense to have them in game if everything is accessing them. So let's, yeah, we'll just make these game width and height. And then in game, yes, we will be complaining. Game width should come first. I tend to say width and height. Okay, so we'll pull those in, and then we can do the same thing for the enemy wizard as well. Great. So we want the game height over 2 plus this. So that is the physical location we want it at. But we then want to subtract the height of the entire image because we want it to, because it has to start drawing from the top right of the image. So that is going to be enemy wizard frame height. If this works, I will be astonished. Yeah, and we'll make the output height. Oh, yeah, actually this needs to be output height, doesn't it? Okay, this might work. Okay, I'm kind of curious whether it will work, but we will find out. So let's, yeah, I already don't like how many different objects we've created on the game control, but I will stick with it for now. Did that do the auto import for us? It did. Awesome. Cool. And then this will be complaining because we don't have a vector of enemy wizards. Enemies. There we go. So we're just going to create an empty vector of enemy wizards, and then inside the update, I think that we will. Sorry, inside. Yeah. Update is different from game update, and that's where we want to do this. Right, game update. So yeah, this isn't looking too crowded, so I don't think we need to worry about that now. Check for presence of wizards. If what's it called? Self.enemies.len is less than 1, then we're going to self.enemies.push, and we go enemy wizards new. For now, I'm going to go with dead center, so 400 and no, it's not, is it? Because we've normalized it to 0 to 100. So 50, 100 should be here at the front, because we're using this mapped coordinate system, which may become a big headache later on, but I think it might keep it simpler, and that's my hope anyway. But yeah, so anyway, 0, 0 is here, 50, 0 is here, and 50, 100 is here, so this end of the corridor. So I'm hoping we should see him in the middle of the screen at the front. And then we need to make sure he's being rendered. So he needs to render before the fireballs, because he should never be able to be behind a fireball. This is interesting, actually. I was thinking about this. What happens if the fireball goes past an enemy wizard and they move in front of it? They should really be drawn in front of it. Otherwise it won't make sense. And at some point, I want to create a rendering type so that everything gets put into this pipeline and then it's shuffled in order of distance. So it renders the most distant things first, and then will render forwards. So it will compose the scene from the back to the front. But for now, we'll just draw each of them. So for enemy in self.enemies.iter, enemy.render at ctx. Great. Well, if we're really lucky, this might work. Oh my gosh, it did. Well, it sort of did. We've got an enemy. He's appeared on the screen, which is great, but he's halfway down the corridor. Now we have to try and figure out why he's halfway down the corridor, not right at the front. He should be down here, but instead he's up in the middle of the corridor. But I do quite like this. I'm actually quite happy with how this turned out. I'm not an artist. That should be painfully clear to anyone here. It's actually why I created the application that I did, because I don't really know how to use a lot of art applications, and that's why I have this, because this makes sense to me. Like, I can at least draw something, and it's a representation of something. At some point, I'd love to delve into like pixel art and get really good at it, but for now, I don't have anything, so or I don't have the skills to do that. So hopefully one day we'll be able to make this game better. But there's our guy, and we can fire a fireball at him, and the fireball will just pass straight through, and the scorch mark will not make sense. And that's why we need to figure out the distance thing. But we've got him rendering, and I think that looks pretty cool. So let's figure out why he's not drawing in the right place. So the logical thing will be to just log a whole bunch of stuff, I guess. Enemy position, go with X and Y. Actually, let's do self.lock.x, self.lock.y, and then the X and Y after. And it doesn't like that because we haven't pulled in glue console log, like this. So that should now, yeah, that should render, and we will pull the inspect, and so we can see it. Oh, yeah, it's showing. Okay, so 5100 and 350, 300. Okay, so we can try and figure out what went wrong with the maths there. The 5100s, so the game height should be, game height over 2, which is going to be 600 over 2, 300, plus self.lock.y times 1.5, so that should be 150, so that should be, oh, hang on, that's not right. that's not right at all. Why is, hang on, 300 plus 150. Yeah, that should be times 2. Because it's game height over 2. Oh, I went from the bottom of the wall, that's why. Hang on. Wait, no, that's the distance from 0 it's 100, and it's 150. It's not game height over 2. It's game height over 2 plus this, plus the distance from the center of the wall to the front. So that will be, how tall is the wall? I can't remember how tall the wall was. So that's about the center, 300. We come down here, and the wall is 346. That doesn't, I think that's 50. But I think we need to add another 50 on there to get the correct location. Because we should be rendering at 350 and we're rendering at 300. Yeah, we're 50 off. I'll just check the back wall, the output. We're just taking the, we're just using the width and height of the actual thing. And the back wall is 96. Okay, so actually it's not plus 50, it's plus, it should be plus 48. Yeah, you know what? I'm going to treat it as 50 because they probably shouldn't be on the wall. So we'll treat it as 50 for now. Everything's saved. Should hopefully see our guy jump to the front. He didn't. He only came up an extra 50. So why? This is minus output height. The output height is 150. Okay, so we're now getting 350. So he's doing the first 350, the x coordinate, that's correct. This is 100, so it should be 350. Why is it not rendering? Maybe we don't need to subtract the height then. That seems very odd that we wouldn't. Is the output height over 2? This is like the worst kind of programming. I'm just slashing at the numbers, trying to make it work. I don't really remember it. No, even that doesn't work. What the hell? Okay, so this is, oops, that was my stream. This is 350, 425. Okay, this is getting even weirder now. I mean, logically that's the number because it would be 75 on top of the 350. So why is this distance not working? Okay, let's break this down. So we start at 350. Oh my gosh, I'm such an idiot. I'm a complete idiot. I got it right. I got the numbers wrong. I added, when I did 600 minus 350, I came up with 150. Congratulations to anyone who was watching that spotted me make that stupid mathematical error. But yeah, so everything was correct before. With the first amount, I was just multiplying by the wrong value. That back in. Yeah, this needs to be 25 because the distance from here to here is 250, not 150, and I'm an idiot for doing that. I'll comment that out because it's quite heavy to ask it to render on every frame. Okay, we're back. We've got something. He's still not in the right position. Okay, so we're going to put this back in, try and see what on earth is going on. We've got our console here. Right, so it's 100 and 350. Yeah, 350 is correct. And we're now getting 400, and that should be 450. So why is that? Oh, okay. Yes, we did also figure out because the wall is an extra 50. So we add the plus 50.0 back in. Nearly there. Gonna comment that out just as a huck up. There he is. There he is. He's right at the front there. Awesome. Okay, so now we're going to make him move backwards. So on every update, we're going to do self.lock.y minus equals delta times enemy wizard speed. And I'm going to create this const up here. 64, and I'm going to set it to 1 for now, and we'll see how fast that. Ah, yes, we're not calling update. We also need to do that. For enemy in self.enemies.iter. Oops. Actually, no, hang on. That's not right. It's a mute. Automatically is mutable, I think. Yeah, you don't have to actually tell it. And then update and diff. There we go. It's the same as the fireball up here. So we should see this guy start to move backwards. Okay, well he he did that very quickly. I don't know if anyone saw that. I'll refresh the page so you can see it. He just shoots off into the distance. So that is way too fast. So we're gonna have to, yeah. And the other thing we want to do is put a limit on that. If self.log.y is less than 0, then self.log.y equals 0. So that he just gets clamped to 0, because otherwise we're going to have to deal with negative numbers, which we shouldn't. And I'm also going to turn this into, I'm going to make that 10 times slower by making it 0.1. Yeah, I've realized why that was. It's because the diff is the number of milliseconds. So yeah, we'll have a look again. That's him. He's still moving quite fast. So I'm going to drop it down again to maybe, let's try another 1/10 of that speed and see what happens. Okay, that's cool. He's moving. It's a little bit slow, so I'm going to ramp that up. Maybe triple his speed. Make it 0.03. Okay, nice. Yep, I think that's a good calm speed. Yeah, he's still he goes from 100 down to 0. So now we need to make him get smaller as that happens, and we do that by returning the get distance, which we haven't done yet. And get distance is going to be actually it's just going to be it's just going to be the lock.y, because it's going to be for 0. No, it's going to be 100 minus that, because we want the distance away from the player. So the player is 0 and down here is 100, and on our mapping coordinate system we made this 0 on the y plane, and so we want to do that. So so it's 100 minus self.log.y. Okay, so the output height is going to be in fact, maybe we don't need get distance for this. Maybe we just use self.log.y. So I think the minimum, I can't remember how fast we made the fireball disappear. Let's have a look at the fireball and see how much the perspective on that changes, because it would be good to keep the same perspectives. The output width is, that's if it's dying. Otherwise, it's time to live. Okay, and how much is the time to live? time to live. Okay, folded all of those. 3,000. Okay, so last 3 seconds, meaning that it's the time to live over the total time to live. So it takes 3 seconds to go from 0 to 100, and it will. Does it, or does it hit the wall? That's what I can't remember how we time to live. Yeah, it just lasts for 3 seconds, doesn't it? Okay, that's not a great way to do the perspective. Yeah, I can see now we're going to need to revisit this when we calculate the perspective. We're going to have to revisit this. Okay, a different tactic. Let's say we want it to be 25% of the original height. So the output height is going to be 25 plus yeah, we should take the frame height into consideration at some point, but we want the 25 plus, and then the difference left is 125, and then it's just going to be a percentage of how far down the hall it is. So it's going to be self.lock.y divided by 100 multiplied by the remainder. So that'd be 125.0. Yeah, let's give this a go, and hopefully. Okay. Yeah, that's a little bit small. I'm going to yeah, I'm going to say that we don't let him get that small. Yeah, maybe 50, and then this becomes 100. And of course we didn't calculate the same for the width. So the minimum says divided by 3. Oh yeah, that makes it tricky, doesn't it? 25 is, see, 25, 50, 75, 100 is 4, 5, 6. That's 6 divided by 6. Okay, let's go with divided by 5, because 100 and 150 divide nicely by 5. So 150 divided by 5 is 30 minus, multiplied by the fact, what we can do is create, yeah, I know what we'll do. So const enemy wizards. Hopefully this isn't just making it more complicated. Back wall size is going to be 30, and the const enemy wizards, back wall height and the back wall width, it's going to be divided by 5, so this will be 20, so it'll be 20, it'll be 20 by 30, which is the same proportions as the image that it's in now. So this is going to be enemy wizard back wall height, and then enemy frame height minus back wall height. Yeah, I've made this a horribly complicated bit of code to read, but I think it should work. And the same for here, but with width. I'll just change width on each of these. Hopefully this makes sense. If it doesn't make sense, please leave a comment under the video, and I can explain how I arrived at these numbers, and maybe do like a non-live version of the of this to explain some of the maths behind the decisions that I've made during this. Cool. So how long have we been going? It didn't say. Okay. Oh, sorry, nearly missed it. So this is the guy going down the hallway. We're starting to get a bit of perspective on the the size of this room now, which I quite like. It does mean the fireball is not getting small enough, fast enough, but that's okay. But we've got this perspective now that it is divided by 5, so it's going to be a fifth of the size when it's at the back wall, which is, I think that's a nice number actually. He is quite small, this guy, but we've got that, so that's good. Okay. Oh, hang on, the width is all wrong. What did I do with this needs to be, no, it is the self.log.y because it's the distance. Sorry, this isn't wrong. The x coordinate needs to be log.x minus output width over 2. Okay, this bit we need to revisit because do we need to revisit? Yes, we do, because we need to take into account the fact that it's not going to be 0 when it's 0. It needs to be, yeah, we need to plus the, and we're going to have to treat it differently based on, okay, so this is my thinking. Sorry, I probably won't do a very good job of explaining this. When it's 0, it needs to be here. When it's 0, it needs to be here. Basically, if the x is less than the game width over 2, then we need to subtract. We need to use that distance calculation, that percentage, to calculate how far left we're going. Otherwise, we need to calculate how far right we're going. And we can probably do this in one calculation, but I think I'll need to draw out 2 calculations in order to be able to figure out what it is, and we'll refactor it down into one calculation later on. But it's going to revolve around the center point. So if self.log.x is less than 50, which remember is our center point for this, then the x will be so I'm going to comment that for now. Self.log.x, yeah, it's going to be the percentage. We're definitely going to need the percentage part, multiplied by game width over 2.0. So this is how far across it's going to be. Game width over 2, yeah, here we go. Right, game width over 2.0 minus that is going to be else we just return this. We'll deal with that later on. Okay, and now we're going to, when we create our enemy, we're going to set his offset to be 0 and see what happens. Oh my gosh, it worked. That's crazy. How did it almost worked? It didn't quite work. But yeah, okay. Right, well that's cool. Well, we're on the right track. Yeah, oh, I know why. Because 0 shouldn't be the center point. We now need to fiddle for the for that. So it's, yeah. So 0 is going to be where are we? We need to be an enemy wizard. Okay, it's going to be the game width minus 2. Okay, so we're going to need the offset. So it's actually not from, it's not from the center point, it's from this point, which we decided was 3, I actually can't remember how big is the back wall. It's 120, so it's 60. So it is going to be game width over 2 minus 30. Right. x min is going to be game width minus 30, and that's going to be our back corner point. So it's going to be that plus it's the game width minus 30. Okay, so it's x min. So it's going to be this definitely needs to subtract minus x min. Oops. And then we also need to subtract it from this. Or do we? Yes, minus x min. No, hang on. It's game width, no, sorry, that's wrong. It's the game width over 2 minus the self.log of y times game width minus all minus x min. Yes. And then this needs to be bracketed just to make sure that we are doing these in the correct order. Let's try that. See what happens. Well, that did not work. That guy is going in the wrong direction. So I'm going to guess it is the. Okay. Okay, I'm going to draw this out. I've got some paper here. So when x is... Oh, we haven't even taken into account the x coordinate. Okay, yeah, that's what's going wrong here. Yeah, it's going to be the percentage offset, right? So we need to get the offset from the... Man, my brain is just not working today. This is... So at a 100 distance, so i.e. right at the front of the screen, we want it to be so x is equal to 0, y is equal to 100. That's right at the bottom left of the corner, bottom left of the screen, and we want that to be the output of that function will be 0 and game height. When x is 0 and y is 0, we want the output to be, what did we decide that was? We think we said it's the game width minus 30, sorry, because it's half. Oh no, it's minus 60. So it's game width minus 60, which would be 400 minus 60, which is 340. Yeah, and then the what did we decide this was? This is the game height plus 50. Game height over 2 plus 50. Game height over 2 plus 50. Okay. And then halfway down, that's where it's particularly interesting. X is still going to be 0. Y is going to be 50. And the offset is going to be between 0 and 340. It's going to be halfway, so it's going to be 170. And the game height will be game height of, which is 800, minus the game height over 2 plus 50, which is 450. That's the total distance we have to play with, which is 350, and it's going to be 350 over 2, which of course is 175. So we need 0 and 50 to be 175. So yeah, sorry, this is not going to be compelling content when I try and figure out maths on a piece of paper. That is not interesting to see, I imagine. But I think that everything has to go from the center point. So we have to subtract, so it's the width over 2, subtracting, and those numbers are interesting. So at 0, 0, it would be subtracting width over 2, which is going to be 400. So we need to make the numbers make 400 when it's at the center point. Sorry, at the bottom left corner. And when x is 0 and y is 100, we need it to be 400. When x is 0 and y is 0, we need the width over 2 minus, so that is 400 minus 60. Okay, yeah. And then when y is 50, we need to be width over 2 minus, okay, 170. So it needs to be 400 minus 170 is 230. 230. Okay, so we've now got a set of differential equations that when it's here, we need the center point 400 minus 400. So whatever value we get out, whatever function we run this through needs to give us from the center point 400, so that we can subtract that from the middle point. When it's here, it needs to be, so halfway down, it needs to be 230. So that we can subtract that point. And when it's right at the back, it's 60. And I think we're going to need to do 60. I think we're going to need to start with 60 because, yeah, essentially here, everything is going to be 0. So whatever calculation, it needs to be 60 plus this distance. So that's going to be a percentage of the, so what's that distance? That's 340. 340? Yeah, oh, this is coming together. This is coming together, yep. So 60 plus 340 times the percentage of distance that we've got. Yep, so that's the, okay, let's give that a go. So it's the game width over 2 minus, and it's this next bit that we've got. So it's going to be the self-developed device. We've got the percentage multiplied by 340, 40.0, and then plus 60. Oh, not end in a semicolon. Okay, let's give that a go. Oops, not open the Windows door, thanks. Okay, that is not right. Oh, I know why, because we actually want to subtract 60, not plus 60. So, hey. There he is. There he goes. Excellent. Right. That is okay. That's cool. He's doing what I expected. As I predicted at the beginning of the video, he doesn't follow the wall because the wall doesn't follow where the maths goes. But that is now working. Okay, that is cool. And now we just need to add in a way of calculating how far we need to add to get this. So when he's at 50, this needs to be we need the output to be 0 so that he goes in the middle. So it's the game width minus that. Yeah, in fact, maybe, yeah. Let's call this X offset. And we can get rid of the game width over 2 part. And then we'll make let X equals X offset. No, hang on. Game width over 2 minus X offset. There we go. Okay, that removes that part. So we take the center of the screen and subtract from that. Now what we need is to add in a component that will add the value across that we've got, and it's going to be 120. Okay, now we need to figure it out for the other side. Okay, so if lock.x is less than 50, else if self.lock.x is greater than 50, else, and we'll just stick the else in there. Oh yeah, we need to return a value. Okay. So we'll return that for now. And we'll go to game, and we'll instead set his X position to be 100. So he should now be on the other side of the screen, but this won't work because we haven't done the maths for this. So it needs to be game.width minus, so we need at 100, something like y multiplied by 340. If I just make that minus, will that work? Yes, yes it will. Okay. So now, okay. So the reason for that is because we just flipped the sign on everything. And again, he's not following the wall because it bulges in, but he ends up in about the right place. Maybe, actually. But yeah, so now we need to figure out the bit in between. So it's always going to be this, and then we need to add the width of the back plus the percentage of this distance. Yes, there we go. Okay, we're zoning in on the correct amount. Right, so. It's going to be plus the whole width. It's going to be the so the whole width at any given time is going to be 60.0 because that's the minimum that it is, plus the percentage multiplied by the difference in that width, which is going to be 740 because it's the width of the screen minus. Okay, so the whole width at any given point is going to be, I don't have enough brackets in here. Do I need Yeah, there we go. Okay, so the hall width at that point is going to be that. And the offset from left is going to be the self.lock.x over 100. Yep, multiplied by hall width. And then all of this, why doesn't it look like that? Plus offset from left. And that is, I think, the whole calculation. Spell lock correctly. Needs semicolons. And we're not using xmin. Okay, we're getting somewhere now. Getting somewhere. Maybe. Nope, we're not getting anywhere. Where the hell did he come from? Okay, that did not work. Okay, so at lock 100, that's going to be 100 times the whole width is going to be 60 plus 1 times 740, so that will be 800. Y equals 100. Whole width equals 800. Okay, Y equals 0. Whole width equals 60. No, the whole width is not 60. The whole width is 120. And therefore, this will be 680. Yep. Okay. Sorry, I was doing half whole width. So the whole width will be 120. Oops. Right. Let's see what happens now. The same thing. But it does end up in the right place. But he starts from way off. Okay, so why is that happening? So at 100, the offset from left. Oh, it's because I'm... Oh, yeah. Don't... It's because I was doing a subtracting. No, it's going the other way. Okay, that didn't really work. Okay, let's get some values out of here and see what is going on. I don't know, or maybe not. Maybe we keep working out. We'll keep solving it for these different places. Okay, so the whole width, that's what we need to calculate at any given time. And when y is equal to 50, the whole width is going to be the difference between those two over 2. So it should be 340. Just separate these. Okay. So self.lock.y is going to be 0. And this is 0 times 680, it's going to be 120. Okay, so that works. When y is 100, it's going to be 680 plus 120, that's going to be 100. That works. And then at 50, it's going to be 0.5 times 680, which will be 340. Oh, hang on, I didn't do that right. Maybe it should be 60. Yeah, it should be 60 because we're dealing with halves. No, hang on. No, the whole width will be 120. Yes, sorry, no. Okay, right, that's the whole width. Okay, and at 50, the whole width will need to be the difference between here and here halfway, which is what, that looks like 220 on there. 120 minus 66, 0 to 340. 0 to 340, and then 460 to 800. I'm hoping it's going to be 340. It is, yeah, so it's 340. Okay. Oh, hang on, that's not right. That needs to be, oh no, that's the whole width. Okay, so the whole width should be 340 when y is 50. So it's 0.5 times that, but it's not because we've got plus 120. So what's going on here? Hang on. So 50%, it'll be halfway from 0 to 340, which is 160, to 800 minus 160, which is 640. So it's 160 to 640. So 640 minus 160 is going to be 540 minus 60, 480, which would be minus 120 is going to be 360. So that needs to be 360. Okay. So the outcome of this needs to be 360, which it wouldn't be. What? Why is this math doesn't make sense? Okay. Yeah, I'm basically going to solve this and then call that a night, I think, because this is melting my brain, and it's not Sunday night was maybe not the best time to try and do this. So it's correct for when y is 100, because that's 1 times 680 plus 120 is 800. When y is 0, it's just 120. And then when it's 50, it should be 360. Is that right? I feel like 0, 340, it should be 170. Wait, hang on. What about, oh, hang on. I've been doing my maths wrong. That's because 340 over 2 is 170. Okay, right. 170 to so then what's 400 minus 170 is 230. Yeah, 230, and then it's going to be 230 on the other side as well, which will make it 460. So the whole width, halfway down, should be 460, which makes sense. Yeah, that's correct. Okay, so it should be 460, and it should go from about 170. So what's 50% then? 170. About there, that's about halfway, isn't it? 170 to 800 minus 170, which would be 630. I just got the perspective on this drawing completely wrong. that was roughly the path the guy traveled when he was going to, the wizard traveled on. Okay, so 460 is the actual width at that point. So then it should be 460. So then half of 680 is 340 plus 120. Okay, that's it. Right, there we go. That's what we should end up with 460 there. So it should be, yeah, these numbers are correct now. Right, and now we've got the percentage of how far across the hall we are. So at 0, it will be 0. Oh, hang on, that's not right. Yeah, okay. Yeah, no, that is right. So the offset from the left one is 0. Right. Sorry, right. Okay, so x is 0, and the offset is going to be equal to 0. X is 100, and the offset will be the whole width at that point, times whole width, and at 50%, x equals 50, the offset is going to be 0.5 times the whole width. Okay, so yeah, that all makes sense. Yeah, because we're dividing by 100. Yeah, okay, that's the offset works. And then we need to yeah, there we go. Plus offset from left. Okay, let's try this guy. Still not working. Okay, let's go back to set the wizard to be 0. In fact, let's create 2. So we've got 2 going at the same time. So we'll have one guy on the right, one guy on the left. Let's see if the guy on the right, on the left works at least. No, they're just trending towards 0, and I have no idea why. So self.log to y. Yeah, so we need to know how far back we are to know how much percentage of 340 we are, which is that, so 340 is this percentage. So at 0, there we go, that's what it is. It's the, yeah. We actually want 340, a lot of magic numbers here, 340 minus that. Let's see if this works. Oh, beautiful. Beautiful. They work. Again, the floor isn't in the right place. But yeah, okay. Well, I'm sorry, stream, that that's taken, a lot of that was just me trying to figure out maths in my head, because it wasn't going very well. But there we go, let's tidy all this up. And then and I'll get rid of my working in here. Oh yeah, actually, I guess let's have a real test. Let's put some more in as well. In fact, actually, let's get rid of the original ones. We'll have one at 25 and one at 75, and they should, not 250, 75. And they work as well. Okay, great. Yeah, so that works. Again, I think the graphics aren't quite working because it feels like they should be. Oh, hang on. I know what's going on. The X coordinate, we need to subtract half of the width. Okay, so we've got all of this silliness going on. This is not good maths. I'm gonna have a think about how to do this. But in fact, I'm gonna do it here. Output minus output width over 2, because we want to. Yeah, it's basically this stuff. But I'm gonna put it in here because it's a bit neater to put it in there. Yes, they end up in the right place. Cool. Well, thanks to everyone. It looks like we've had 4 views, and thank you very much for everyone who stopped by. I will push this code. I'll update the notes on this video so that when it's published, it'll have more information. I'll try and include a link to the Pixel app application as well. Thanks very much for watching, sticking with the incredibly boring maths content. Once we've got a few of these going, it becomes really easy to reuse them. So yeah, I'm sorry that it's taken so long to figure that out, but that was what I wanted from the stream, was to be able to offer game development, warts and all, in the way that it's made, and or at least, sorry, not the way that it's made, the way that I'm making this game, warts and all, and so that you could see the entire journey. And as you can probably tell, none of this has been rehearsed or anything else. I probably will at some point do some cleaner videos with explanations of each thing, not explanations of each thing as I figure them out myself. But yeah, cool. Anyway, thanks for joining for now, and yeah, hopefully see you again in about a week if inspiration hits me and I feel like doing just that. But for now, I will wish you a good day. If I can get to OBS, which appears to have crashed. There we go. Yep, cool. Well, thanks very much, everyone. Take care, and hopefully see you again soon. Bye for now.